Okay, welcome back, guys. We're still on page 42. This time we're looking at problem F. Cotangent of t equals negative square root of 3. So, just like the last few problems we did, the first thing we want to do before we start is look at the definition for cotangent on page 34. Cotangent is defined as the x-coordinate over the y-coordinate, or cosine over sine, since cosine corresponds to x and sine corresponds to y. It's the same thing. So, let's go ahead and write that down. I'm going to use a separate sheet of paper because I know I'm going to run out of space otherwise. So, cotangent of t equals negative square root of 3. Cotangent is the same as x over y, or cosine over sine. And then we know that that is equal to negative square root of 3, since cotangent is equal to negative square root of 3. Okay, now unlike the last few problems we did, we can't just go ahead and solve for a variable because we have two unknown variables here. So this time we have to do a little bit of thinking. So we know that x over y, or cosine over sine, is equal to negative square root of 3. That can happen in a few ways. We can get a negative number through dividing two different numbers if one is negative. So if we have x is negative and y is positive, or cosine is negative and sine is positive, then we can get a negative number out. Similarly, if cosine or x is positive and y is negative, or sine is negative, we can have another negative square root of 3. Okay, so now we just have to look at the unit circle and see where that might happen. So where on the unit circle is cosine negative and sine positive? Quadrant 1, both of them are positive, so that can't be the quadrant we're looking at. In quadrant 2, we have cosine is negative and sine is positive, so that definitely works. And then we also need sine to be negative and cosine to be positive in another quadrant. So where can that happen? In quadrant 3, both are negative, so that's not going to work. In quadrant 4, cosine is positive and sine is negative, so that's the quadrant we were looking for. So that means both of our answers, one will come from quadrant 2, and one will come from quadrant 4. Okay, now let's try to figure out which angle it is. We know our answer, when we divide the x by the y, gives us negative square root of 3. So we should be seeing a square root of 3 somewhere in our coordinates. So that tells us that 315 degrees, for example, can't be our answer because it doesn't have a square root of 3 in it. So then we just have to figure out which one it is between 300 and 330 degrees over here. So if we divide the square root of 3 over 2 by negative 1/2, let's see if we get square root of 3, negative. So let's divide square root of 3 over 2 by negative 1/2 and see what we get. So remember, when we divide by a fraction, we take the reciprocal of the fraction and multiply. So we end up getting the square root of 3 over 2 times the reciprocal, or negative 2 over 1. Now let's just multiply the numerator, or the top. Negative 2 times square root of 3 gives us negative 2 square root of 3 on the top. And on the denominator, or the bottom, we get 2 times 1, which is just 2. Okay, now negative 2 divided by 2 is just negative 1, right? So we get negative square root of 3, because the 2 cancels out. So that's exactly what we're looking for. So that tells us that 330 degrees is one of our answers. Because when we divide the square root of 3 over 2 by negative 1/2, we end up getting negative square root of 3. So t can be 330 degrees. Or 11 pi over 6 radians, same thing. I'll go ahead and write that on the paper as well, page 42. So t is equal to 330 degrees, or 11 pi over 6 radians. Okay. Now try to figure it out on your own. In quadrant 2, what should we use to get a negative square root of 3 for cotangent? Okay, now let's come back. Now, the value you should choose should be in the same order as before, because when we divide the square root of 3 over 2 by 1/2, we end up getting the square root of 3. This case is going to be the opposite in signs, so we have negative square root of 3 over 2 instead, divide by positive 1/2. And that should give us negative square root of 3. So that's at 150 degrees, or 5 pi over 6 radians. So t, I'll just go ahead and write right here, can be 150 degrees, or 5 pi over 6 radians. Okay, perfect. So again, that just means at 330 degrees, when you divide cosine over sine, we get negative square root of 3. And at 150 degrees, or 5 pi over 6 radians, when you divide cosine by sine, you get negative square root of 3. Okay, now we just need to find the reference triangles for 330 degrees and for 150 degrees, or 11 pi over 6 radians and 5 pi over 6 radians. Go ahead and pause the video. Try to find the reference triangles on your own. Okay, now let's come back. So for 330 degrees, we highlight the terminal side, and we connect it to the initial side, or the x-axis. And there's our first reference triangle for 330 degrees. Let's just sketch that on page 42. Okay. Now, our reference triangle for 150 degrees. Again, we connect the terminal side at 150 degrees to the initial side, or the x-axis. Let's go ahead and sketch that on page 42. Okay, perfect. So we found both of our reference triangles for 330 degrees and 150 degrees. And we found that at 330 degrees, or 11 pi over 6 radians, cotangent is negative square root of 3. And at 150 degrees, or 5 pi over 6 radians, cotangent is negative square root of 3. That's letter F, and that's it. Thanks for watching, guys.